everyone. It's really nice to be here. It's my first time in Estonia, and I'm super honored to be here talking about what we do at LanzaTech. LanzaTech, first, I'm innovation manager. My background is biology. And I worked until very recently with the synthetic biology group. So synthetic biology and biomanufacturing are my main, metabolic engineering are my main backgrounds. And at LanzaTech, we do gas fermentation. And I'll talk more about that in a minute. We went public last year, and then I just have to show this slide for whatever I say. But yeah, and this is why we are doing what we are doing at LanzaTech. As I said, it's a gas fermentation company. Instead of sugars, it uses carbon oxides like CO, CO2s from waste sources that otherwise would go to the atmosphere. So with this, we really want to bend this curve and not face the climate crisis that we are about to suffer. So what we want to do is to make a difference in this realm. And also, it would be very smart and very clever for any region to be energy sufficient and not rely only on fossil fuels. We are seeing with COVID and the wars that we cannot rely on only one source of energy as a country. And talking about decarbonization, of course, there are some fields that can be carbon-free as power, but there are other fields that cannot be carbon-free. So when we talk at LanzaTech about decarbonization, we actually change the word and talk about defossilization, not using as much fossil fuels as we are using today and make the carbon balance pretty bad, but rather tap into these fuels and chemical markets by reusing carbon to make the products that we use in our daily basis. So that's our mission. We believe that it's very important to know where our carbon is coming from, if it's either from the below ground or if it's being reused it's being reused in. The waste is not going to waste. Carbon is too precious to go to waste. That's my message. We use anaerobic acetogen, a bacteria that was first isolated from rabbit poo. So it's a pretty resilient and robust microorganism. And this microorganism, as I told you, instead of sugars, it uses gases that are pollutants to produce. In our case, we are producing ethanol at commercial scale. This is how it works. This is our bioreactor. We consider the bioreactor as our hardware, so we don't change the bioreactor. And we have our microbes inside this bioreactor. And these microbes are being fed with industrial off gases that we pump and bubble in this bioreactor to be available for the microorganism, and it uses these gases as a source of energy and carbon. We can also gasify agriculture and municipal solid waste and feed the microorganism. And we can also, if we have a source of energy, we can also use electrolysis coupled with the CO2 that is being emitted in the atmosphere to also feed the microorganism. And with this, we produce fuels, chemicals, materials, dresses, clothes, cleaning products, you name it. And we also take advantage of the bacteria, the high protein amount of the bacteria, and we spray dry it and sell as a feed for fish. So it helps with the economics as well. And this is our idea of circular economy. Eventually, this is going to be waste again, and we put again in this pipeline, so we don't have to mine fossil from the ground again. This is how it looks like in the real life. We have 6 commercial plants already. This is our plants here, 3 plants, and this is ArcelorMittal in Belgium. So the gases that would go to the atmosphere, they go to the brewery, and the microorganism produces ethanol using this carbon. Of course, this was the hardest part and more costly for us, the scale-up process, but having the R&D, the biology, and the engineering the software and hardware since the very beginning in mind, and on the design, considering the design was what made us successful. We have also partnerships with Zara, brands like Lululemon, Gucci, L'Oreal, and we produce with this ethanol sustainable aviation fuel as well. So we have been partners with these brands. So they use the ethanol either directly, as in the perfume and cleaning products, or in the ethylene pipeline for clothes and shoes. And again, it's going to, all of this is going to be trash again that we want to reuse again. We also have a spin-off called LanzaJet, so part of our ethanol is being transported to this unit, and this unit is chemically converting in sustainable aviation fuel. At this point, with the 6 commercial plants, we avoid 500,000 tons of CO2 to go into the atmosphere, and with this CO2, we produce more than 300,000 tons of ethanol. But we want to produce other things, not only the ethanol. We want the software to be more flexible, so we are modifying it genetically to produce other things other than ethanol. And this is IPA, acetone. They are in pre-commercial stage, and other things like butanol and monoethylene glycol. We have an R&D team there. This is me pretending I'm working. And we have all the R&D capabilities in fermentation. We have an anaerobic biofoundry as well. It's the only one in the world that is completely integrated. And we collect and use a lot of this data that we collect since the lab up to the commercial scale to understand and to learn from that, so we don't take as much time as we took the first time to put a product in the market. That's what I just said. So since pathway discovery in the lab up to our bioreactor, we collect data about everything all the time, 24/7, to understand and learn how we can speed up our process using AI and modeling for this. Of course, it's not only data and time and investment, but also our team is really unique in the sense that it's pretty diverse. We take this into serious consideration. These problems are so complex that we need to solve that we need a lot of different backgrounds and expertises on the table to discuss those things. And of course, what we think that is possible in the future are just predictions from the past until we see that we can do something different. And with this message, I want to thank you very much for being here, listen to what we do. And together with my colleagues, we are here to ask any questions. And my contacts are here as well in case you want to discuss even further. Thank you so much.